In this example, we're again going to use trig identities to help us simplify what's in that integrand to make it something we can integrate in a much more straightforward manner. So in this problem, we're looking at a sine squared times cosine squared. The first thing we should notice is, well, the sine has an even power attached to it, as well as that cosine also has an even power. Now, in this case, both sine and cosine have even powers, so there's a specific identity that we use in this case. And those identities are our half-angle identities. So we have two identities. Sine squared is 1/2 times the quantity cosine 1 minus 2x, and a cosine squared is 1/2 1 plus cosine of 2x. And when all the powers of sine and cosine are only even things, we just keep substituting these identities in for those even powers of sine and cosine. So in this example, we're going to first substitute in for sine squared of x, using that half-angle identity, and then next we're going to substitute in for that cosine term, or cosine squared term. So substituting in the sine squared, from the half-angle identity, we get 1/2 times 1 minus cosine of 2x. Next, from that cosine term, so again, this first thing is our sine squared, or previous sine squared. Next, we'll substitute in for the cosine squared term, and that is also a 1/2 times quantity, 1 plus, this time, a cosine of 2x. Again, that was our cosine squared previously. And now what we see is we're going to be able to do a little arithmetic, a little bit of algebra, and reassess the integral that we have here. So I'm going to pull both these factors of 1/2, multiply them together, and bring them in front of the integral. So that'll give us a combined 1/4 times the integral of 1 minus cosine of 2x times 1 plus cosine of 2x. Next, we're going to distribute, or FOIL, if you will, all of these terms out to see what we have left in that integrand. So again, we have 1/4. Multiplying this 1 times 1, we get a term of 1 times cosine of 2x, a plus cosine of 2x. Next, we'll substitute that minus cosine of 2x times 1. So we get a minus cosine of 2x. And then finally, distributing it into the last, we get a plus cosine squared of 2x term, dx. Now, inside of this integral, again, we're reassessing to see what things can we just integrate in a straightforward manner, what things do we do a little more work on. Well, some simplification occurs here. We're able to cancel out both of those cosine of 2x's because they have different signs. So the integral we're looking at now is 1/2 times the integral of 1. And since we are adding or subtracting things, we can split into two integrals. So plus 1/4 times the integral of that cosine squared of 2x term. Now, this first integral, this is something that we can do. We know how to integrate constants. And in fact, if we were to integrate it, we know that the integral of just 1 with respect to x, this thing will actually just give us a 1/4 x plus c type term. I'm going to save that to the very end until we can just integrate both integrals at the same time. So the spoiler here, we're going to get to do a little more work on this integral on the right-hand side. So again, reassessing what we have in that integrand to see how can we integrate what's left. If we look, we have a cosine to a power term. And in this case, just like the beginning of the problem, it just so happens that this cosine has an even power only. There's no other sine term. Oh, I need a dx there. There's no other sine term there. So we just have an even power of, this time, cosine squared of 2x. So what are we going to do? We're going to use the half-angle identity again. This time, however, we have a cosine of 2x. So in the original half angle identity that we had above, we had basically something going from a cosine squared of just x into a term involving a cosine of 2x. So in this half angle identity down below, we're going to go from a 2x into a 4x in the identity. So I'm just going to write this identity that we're going to use. It'll be cosine, oops, not of x, but of 2x, is equal to 1/2 times the quantity of 1 plus, this time, a cosine of 4x. Again, going from a 2x in the cosine squared to a 4x, or doubling what that argument was. So let's go ahead and substitute that into the integral. This first integral stays the same. It's still a 1/4 integral of 1 with respect to x. We have a plus 1/4 times the second integral, and we'll go ahead and substitute in this second half angle identity now to help us out. So inside that integral, we have a 1/2 times the quantity, 1 plus cosine of 4x. And we're integrating that with respect to x. So let's just rewrite what we have. We have this first integral, 1/4 integral of 1 dx. You might be itching to integrate that. You can do that if you want now, or just save it to the end. Next, what we see is, well, we have this factor of 1/2 inside of the second integral, so we can just take that out in front, multiply the 1/4 and 1/2 to give us a plus 1/8. And then inside this integral, we have a 1 plus a cosine of 4x. And both of these things we can integrate in a more straightforward manner now. So let's just go ahead and perform all of these integrations. So in this first integral, we have the integral of just, well, 1/4 times the integral of 1. Again, that's just going to give us an x. Now the second integral, we have 1/8 times whatever those antiderivatives inside of the integral are. So the antiderivative of 1, again, with respect to x, is just x. Now the antiderivative of that cosine of 4x, they'll give us a positive sine of 4x. But then we also need to divide by 1/4 as well. And then we have a plus c at the very end of our antiderivative. And there's some things we could recombine here, like we can distribute this 1/8 into both terms and stuff like that. Maybe combine the 1/8x with the 1/4x, but this really is the bulk of the antiderivative in this case. So just to bring us back through this entire problem, we started with sines and cosines that were both raised to even powers. And when this situation arises, we use the half angle identities and replace both sine squared, cosine squared, all of those even power terms with half angle identities. And then inside, once we do that substitution, reassess after we do some algebra and see what else is left over, and keep using identities as need be.